Scientists use information about seismic waves from earthquakes to find out about the internal structure of the Earth. The diagram below represents a circular cross-section of the Earth. The dashed curve represents the path of a seismic wave travelling through the Earth from an earthquake near the surface at A to a monitoring station at B. The radius of the Earth is 6.4 units. So that's the distance of A to O. The path of this wave is a circular arc of radius 29.1 units. So this is the path of the wave. It's a circular arc. Its radius is 29.1 units. So the center of a circle that contains this arc is going to be somewhere out here. And the radius is this distance here, which is 29.1 units. And it's going to be the same as this, of course. The distance from the center of the circle to B is also 29.1. 1 unit is 1,000 kilometers. So the radius of the Earth is 6.4 units, which is 6.4 by 1,000, or 6,400 kilometers. Based on information from other stations, it is known that this particular path just touches the Earth's core. So you can see the path of this seismic wave. It's just touching the Earth's core here. The angle AOB measures 104 degrees. AOB is this angle. Okay, it's the angle between the arm AO and the arm OB. What we want to do is find the radius of the Earth's core. The radius of the Earth's core is this distance here. I'll just call it R. Now there's 3 ways we can do this problem. The first way I'm going to do it is by considering this triangle here. And looking at this angle in here. By symmetry, this line here will bisect this angle of 104 degrees into 2 angles of 52 degrees each. So the angle in here is 52 degrees. Okay, we have that symmetry. What we should consider doing next is to calculate x, where x is this distance here. This distance is x. When we found x, we can find r. R is this distance, by simply subtracting away the distance from here to here, because the distance from here to here is the radius of this arc. The radius is 29.1. So we'll get x first of all, get this distance. Now, we could use the sine rule to get this. We just need pairs of corresponding sides and angles. We can't get x directly because the angle corresponding to x is this angle here. We don't have that angle and we can't find it because we've only got one angle in this triangle. It's 52 degrees. We don't actually have a way to get these 2 angles. Not easily anyway. So what we will do is start by getting this angle here. So I'll call this angle y. Or actually I'll just call it A, not to be confused with this A. And the sine rule says that a side and a corresponding angle are related by 6.4 over sine A equals another pair involving a side and a corresponding angle. So we've 29.1 over sine 52. So this is just the sine rule, where A is 6.4 and the side opposite A, little a, is capital A. So little a is a side, capital A is an angle. And another pair would be little b is 29.1 and the angle corresponding to it is capital B, which is 52. So little a over sine big A equals little b over sine big B, essentially. And we just rearrange this to find sine A. So we just cross multiply 29.1 sine A equals 6.4 by sine 52. So if we take 6.4 times sine 52 and divide by 29.1, we get sine A. So sine A is 0.1733 and we get inverse sine of 0.1733 to get 9.98 degrees. So having found A, we can then go and find this angle up here because the 3 angles add up to 180 degrees. So these 3 angles add up to 180, so I can find this angle. It's 118 degrees. Now we can find x. We just use the sine rule again. We just have a side and its corresponding angle. X over the sine of the angle opposite x, which is 118 degrees, equals, now we need another pair. So we can use this side here, 29.1 divided by sine 52, or we can use 6.4 divided by sine 9.98, as long as the side and angle are opposite each other. So I'll use 29.1 divided by the sine of 52 degrees. And to find x, what we do is we just cross multiply x sine 52 equals 29.1 times sine 18. So we multiply 29.1 by sine 118, and we divide that answer by the sine of 52. So if you do all that, that's just rearranging. You get x equals 32.6 units. So that's x. That's the distance from O to the center of this circular arc. So how do we get the radius, this distance here? This is r, the radius of the Earth's core. Well, we just have to subtract away this distance here. So I explained this to you earlier. The distance from here to here is just the radius of the circular arc. It's just 29.1. That's that yellow distance here is 29.1. So we have that r is the total distance from here to here, x, which is 32.6, minus 29.1. We get 3.5 units. 1 unit is 1,000 kilometers, so 3.5 units is 3.5 by 1,000, or 3,500 kilometers. Another way that we can find x in this triangle is to use the cosine rule. What does the cosine rule say? It says that for little a, which is a side, a squared equals b squared plus c squared. So the small letters are sides, minus 2bc cos capital A. So small a, b and c are three sides of a triangle, but it's important to realize that this side here is opposite this angle. So the capital letter is an angle. Now, what are we going to let little a equal? We can't let little a equal x because we don't have capital A. If little a is x, then capital A is this angle up here. It's the angle opposite little a. We've no way of getting this angle. We've only one angle in this triangle. So we can't let little a equal x. We can let a equal 29.1 because then the angle opposite 29.1 is capital A. So capital A will be 52 degrees. Forget this a here. So there's a pair. We have a side and its corresponding angle. What about B and C? Well, B and C are the other two sides of this triangle. So we can let B equal either 6.4 or x, it doesn't matter. I'll let B equal 6.4, which means that small c is x. And we can plug all this into this formula, and the only thing that's unknown is x. So A is 29.1. That squared equals b squared plus c squared. That's 6.4 squared plus c is x squared minus 2 times 6.4 times x times the cos of A. Big A is opposite small a. Big A is 52 degrees. Now we see that this equation is a quadratic equation in x, because we have an x squared term and we have an x term, x to the power 1. We can't combine these, of course. So I've written down the x squared term here. If we multiply minus 2 by 6.4 by cos 52 degrees, we get minus 7.88. 29.1 squared is 805.85. So we write this equation in the standard form of a quadratic equation with 0 on the right hand side, and then we go ahead and solve it. Now I won't go through the solving of this. I'll just write down the two values. You get two values for this. One of them is negative. That can't be correct because x is a distance. So here's x. This is what we've seen already, 32.6 units. And to get r, well, we do what we did previously. We just take 32.6 and subtract away this distance here, which is the radius of the circular arc. And you've seen this already. So we get the same answer as before. Now there's one other way of doing this. Here's the setup as before. If you didn't know anything about the sine rule or the cosine rule, you could use basic trigonometry and Pythagoras Theorem to calculate the distance from here to here. This is what we called x previously. What you can do is break this triangle into two right angle triangles. In this right angle triangle here, we can use basic trigonometry to find this green side. This is the side adjacent to 52 degrees. The hypotenuse is 6.4. So the ratio that brings in adjacent and hypotenuse in a right angle triangle is the cos. The cos of 52 degrees is the adjacent, I'll call it A, divided by the hypotenuse, which is 6.4. So that side adjacent to 52 degrees in this right angle triangle is 3.94. Now we have to find a distance from here to here. How do we do that? Well, we have another right angle triangle here, but we've only got one side. We've only got the hypotenuse of it. If we want to find a distance from here to here, we'd have to get this blue side. And then we can use Pythagoras Theorem to find a distance from here to here in this second right angle triangle. If we have two sides of a right angle triangle, we can find the third side by Pythagoras. So how do we find this blue side here? Well, we notice that this blue side is the side opposite 52 degrees in this right angle triangle. So we see that the sine of 52 degrees is the side opposite 52 degrees, I'll call it little b, divided by the hypotenuse of this right angle triangle, which is 6.4. So I get that b is 5.04. So now I can apply Pythagoras' theorem to this triangle to find out what this side here is. So what does Pythagoras' theorem say? It says that in a right angle triangle, the longest side squared, or the hypotenuse squared, which is 29.1, that's the side opposite the right angle, is the sum of the squares of the other two sides. So we square the other two sides and sum them. So we solve this equation to get y equals 28.66. So that's the yellow distance. So now we can get x. We just add 3.94, this is the green distance, onto the yellow distance, which is 28.66. So this is the result we got before for x, and the rest just follows. So you know what to do. This distance here is r. So if we want to find r, we take the total distance from here to here, which is 32.6, and we subtract the distance from here to here, which is 29.1. And we get 3.5 units, which, as we saw before, is 3,500 kilometers.